Thanks, Nick. Yeah, so this was going to be my talk, from jQuery Mobile to React Native, but I changed my mind a few days ago about what I was talking about. But I'll quickly introduce myself. My name's Colin Eberhardt. I work at a company called Scott Logic. There's a few of us around, and I spend most of my time writing financial softwares for banks and being very, very sensible and, hopefully making good decisions. And the talk I was going to give was about cross-platform mobile application development and about making sensible decisions. But I thought that's a bit boring. At this time of day, I don't want to be sensible. I just want to talk about what's cool. And that's what I'm going to talk about. So the session's been changed to Geeking Out about React Native. And the reason for that, as hopefully you'll find out, is React Native might not be the best cross-platform framework, but it's certainly one of the most interesting from a technical perspective. There's lots of fascinating things within React Native, and that's what I'd like to talk to you about today. But before doing that, I would like to set the scene a little bit. So of the talk I was going to give, there's just one slide left, and this is it. And as you can tell, I was a bit bored, so it's just bullet points. But I do want to set the scene a little bit and tell you a little bit about the context that React Native lives within. So a lot of the work I do, as I said, working with banks, is trying to convince them that mobile technology is a good thing, it's something they should be investing in, and I doubt I need to say any of that to you guys. I'm sure you're all behind it. The problem becomes, if you're going to release a mobile application, is how do you build it? Which technologies to use? And sort of classically speaking, there are three different options. The first one is the native option. So for iOS, Android, BlackBerry, maybe Windows Phone, you use the native implementation technologies, and you basically do the same work 2, 3, or 4 times over. Other options are mobile web. Most mobile phones have a really good web browser. They adopt many of the modern standards, and that's another way of delivering your application. So rather than having an installed application, you write a web app. The final one is hybrid. This is taking exactly the same HTML5 content that you'd use for mobile web and wrapping it up in a native wrapper. Things like Apache Cordova, which was previously PhoneGap, is a very popular way of doing that. And one of the advantages there is it gives you a way to shim some of the things that aren't available to you via mobile web, so things like access to the accelerometer. And it gives you the best or the worst of both worlds, depending on your perspective. And this particular subject has been an area of pretty intense debate and argument for the past couple of years. You'll find people very passionate about one solution or very passionate about another, and there isn't really much agreement about the best way to do it. But the one thing that I always find seems to be missing from the list, you see a lot of articles about HTML5 versus native. The one that seems to be glossed over is native UI. And one of the issues with HTML5 on the web is usability, UX. You might have heard the phrase janking, the striving to reach 60 frames per second. If you deliver a native user interface, typically you avoid some of those concerns. And technologies have been around to do this for a long time. Titanium's one of the first one I was aware of, which is a JavaScript engine that renders a native UI. Xamarin allows you to do it with C#. Telerik have produced NativeScript, which is a JavaScript derivative. And then there's React Native. And again, I'm not going to talk about the others. It's not because they're not any good. There's some decent solutions in there. But personally, I find React Native the most interesting from a technology perspective. Yeah, React Native is technically awesome. Now, before you can understand React Native, you need to know a little bit about React. So it'd be good to get a show of hands. Who's used React in the room? OK, maybe a third. So I think before talking about React Native, I want to talk specifically about React. And the way I'm going to do that is illustrate a very, very simple application, and first show you that application implemented with vanilla JavaScript. And I'll show you the application. It's really, really simple. It's a button, and as you click it, it tells you how many times it's being clicked. And as you go beyond a certain number, it turns a kind of pinky reddish color. So a very simple application. And I'm going to show you how that could be built with vanilla JavaScript. And by vanilla JavaScript, clearly I mean jQuery, because you wouldn't be so crazy as to use the DOM APIs directly. I mean, that would be insane. So if you look at the top, we've got the HTML markup for that. It's pretty self-explanatory, a div, a button, a span, and we've got classes that from our JavaScript, sorry, from our jQuery, we can locate these elements and perform logic with them. The JavaScript is very trivial. All it's doing is, firstly, it's obtaining references to these DOM elements. We've got the next couple of lines are our application state, so the number of clicks and whether we've reached too many clicks, which flips the color. And then we've got basically 2 blocks of logic. The first, update UI, is responsible for taking the model state and pushing it to the DOM, so updating the UI. The second block is our button click. And again, don't worry about the details, but basically that's responsible for handling user interactions and updating the model state accordingly. And finally, on initialization, we have to take our model state and apply it to the DOM. It's very simple, very straightforward. But in doing that, we have quite a complex interaction going on here. We've got our model state on the left-hand side, and we've got our UI state on the right. And we're manually managing various different flows of data. So user interactions flow as event handlers to update the model state, and then we have to, on initialization and on model updates, we have to update the DOM. That's quite a complex thing to do, and it's also quite fractured in our code. The code that's responsible for each of these paths is quite separate. It's not a very pleasant way of doing things. So rather than using vanilla JavaScript, most people use some kind of MVC framework, and I'm not going to go through all of them because that would take a while. I'm just going to look at Knockout, and my main reason for choosing Knockout is just because it's one of the more concise MVC frameworks. Angular is probably the most popular, but Knockout just allows me to do it with a little bit less boilerplate. So here we have exactly the same application written in Knockout. And here you can see the code looks quite different. So the DOM looks relatively similar, but this time we've got these data bind attributes in there, which are providing data binding expressions. The code looks very, very different. Rather than managing these 2 flows of data, the code is now a view model. It's a model representing our current application state. Our model just has a number of clicks observable property, and when the button is clicked, we update that. And Knockout takes care of the data flows for us. The final line there, apply bindings, is basically the bootstrapping. So what we've done here is we've replaced the sort of complex flows of data where we had these 3 different paths, and we've replaced it with something a lot simpler. Our model state is now bound to our UI state, and we don't have to care about these different flows of data. And this is just an illustration of how it works in Knockout. It's pretty similar in Angular and other MVC frameworks. A lot of what they're doing is removing the need to manually manage the different flows of data by some form of binding. But some quick observations on Knockout. One of them is it allows us to have a little bit of logic within our HTML. If I quickly wind back, one of the things you can see here, I don't know if you can just about see the cursor, is when the number of clicks exceeds 5, we apply a CSS class. And here we've got the logic within the HTML. It's something this allows us to do. It may be good, it may be bad. One other observation on Knockout is it's got a very clumsy property syntax. Now, I'm picking on Knockout a little bit here, but a lot of these observations are quite true of any other MVC framework. So I actually quite like Knockout. These are sort of general observations. But one of them is that we've got a clumsy property syntax. What I really want to say is this. Within my model, I want to just increment the number of clicks. Whereas what I have to say is this. Because JavaScript doesn't have a built-in concept of observable properties, Knockout has its own implementation, so rather than having variables, they become functions which emit to their subscribers. So that's a bit clumsy. You also have to have the concept of observable arrays if you're going to be rendering a list of things. And again, going back to the clumsy property syntax, Angular solves this in a completely different way. But again, it has to do something quite smart to be able to observe the model. You've also got some sort of templating or binding mini-language. So what this means is your HTML has a sort of funny little language for for example, for binding to arrays. You've got some templating concepts in there. And you find this outside of MVC frameworks as well. If you've ever used things like handlebars, which is a relatively dumb renderer of data, they have some kind of sort of mini language that goes along with them. Knockout gives you a separation of concerns. So you've got your HTML, which is one concern. You've got your JavaScript, which is another concern, and your CSS, which is another concern. And this is one of the things that React has really been pushing, that a lot of the other MVC frameworks don't provide separations of concern. They provide separations of technology rather than separations of concern. So my concern here, the thing I'm interested in is my button that counts the number of clicks. I'm not really interested in the fact that it's implemented with effectively 3 different technologies. But a lot of the MVC frameworks push that separation. So this is where React has come from. And again, this is why I want to go through React a little bit first, is to show you that React itself is a pretty radical approach. It's a very different flavor of MVC framework when compared to most of the others. So here's exactly the same thing implemented in React. I can click the button, and it goes a funny color. And this is what it looks like written in React. And this probably looks a little bit alien compared to the others. So I'm just going to point out a few interesting things. The first thing I'm going to point out is this bit here. This is the rendering logic. Whereas with Knockout and Angular, you typically have a HTML template which is separate. Here, our click counter is a component, and the HTML is embedded within it. And as you can see, it is actually HTML in line within your JavaScript code. And this is because your React code is transformed before it's sent to the browser. Originally, they had their own transformer. I think it was called JS Transform. It now uses Babel, which supports JSX, which is this JSX gives you the ability to mix markup within JavaScript. So it now uses Babel to perform this transformation. So this is where our HTML has gone. We've also got this notion of state. So our React class has an initial state, and when the button is clicked, the state is updated. And the one thing you might be wondering about is where is this sort of connection gone? When the button clicks, the state updates. So how is the HTML updated? And that's probably the most interesting thing about React, is it just re-renders the whole thing, which is quite interesting. What happens is, with React components, the views become a transformation of the current state. So your view is a straightforward representation or transformation of your state. There isn't this sort of complicated relationship between all the different component parts of your view. It's a simple, straightforward transformation. And the way that this actually works in practice is the HTML that you saw within the render function turns into a virtual DOM. The virtual DOM is then diffed with the real DOM, and then React works out the updates that are required to update the state of the real DOM, which is pretty impressive. It's crazy clever stuff. And when this first came out, it was just a few years ago, people thought this was pretty insane. It sounds insane, but it actually works quite well. But I'm not interested so much in the particularities of how it works. What I find more interesting is the approach and the elegance of the elegance of this. So it provides a separation of concerns rather than technologies. So something we've been doing for a while is we've been believing we're separating concerns by putting HTML in one folder and JavaScript in another folder, but we're not really separating concerns. ReactJS really is a separation of concerns. One other thing you'll notice with ReactJS is that you have inline styles as well. And styles have been, CSS has been something that's been quite hard to manage for a long time. While we've got things like JavaScript modules, we can transpile our JavaScript, we can do a lot with our JavaScript. CSS, you pretty much run it through a preprocessor, and that's it. It's not connected in any way with our HTML. So one of the big problems you get with large JavaScript applications is dead CSS code. And there's no way of removing that easily, because it's just separated entirely. Whereas with ReactJS, by having the CSS within the component, you can do dead code elimination. There's also quite a lot of other good reasons for mixing CSS with JavaScript. I'm not going to go into that in too much detail, other than saying, have a look at the talk CSS in Your JS by Christopher Shadu. That might be how you pronounce it. He's actually one of the guys behind ReactNative as well, but that's a talk that's well worth watching. One of the other things is performance. When it first came out, it was heralded as a fantastic boost to performance. I'd take that with a bit of a pinch of salt. I think as developers, it's all too easy to rely on the framework to give you performance rather than relying on your understanding of the framework and using it properly. And after some of the demonstrations of React performance versus Angular performance, they were refuted in a few cases by demonstrating that they weren't actually terribly good examples. So again, getting to the fundamentals, the thing I like about React is the elegance and the approach, having your view as a transformation of a current application state. All this other stuff, to my mind, is good, but secondary to that. So if we focus on that, if we look at how other MVC frameworks work, this could be Knockout, it could be any of them. On your right-hand side, you've got the DOM, and your left-hand side, you've got your application state, in whatever form that might be. That might be a view model, or it might be your vanilla JavaScript code. And as I mentioned, there's quite a deep and detailed relationship between the two. We've got references to DOM nodes and event handlers going back the other way. And it's quite tangled and closely coupled. The two are inseparable as a result. But this is how, sort of conceptually, it looks with ReactJS. You've got your application state that renders to a virtual DOM. That's then diffed with the real DOM, and updates are sent to the DOM. It gives us quite a separation. We've effectively got a pipeline. Application state is rendered to a virtual DOM. It's then sent through a pipeline to update the real DOM. We don't have this tight and deep coupling with it anymore, which is quite elegant. And it sort of leads to the question, if the DOM is decoupled, perhaps it can be replaced. So rather than rendering to a HTML DOM, maybe we could create a tree-like structure and do something else with it. And I know what you're thinking. You're going, yeah, the next slide's going to be React Native. It's not. It's a different one. I don't know if anyone's seen this, but it's a company called Flipboard. And getting back to HTML5 and mobile, they were adamant that they wanted a very modern, very slick-looking user interface on mobile, but they wanted to do it with HTML5. God bless them. So what they wanted to do was have scrolling and parallax. And if you've done anything with mobile web, you'll know that doing stuff while scrolling is a really bad idea. The mobile browsers have been written to a certain extent in such a way to try to stop you from doing this sort of thing. Up until recently, you didn't get scroll events. So they are doing something that's technically quite hard. And the way they solved it was to get rid of the DOM altogether and render to canvas. They created their own canvas, well, their own effectively DOM-like representation that rendered out to a canvas instead. And then they thought, once they'd got that, how are we actually going to marry that with our application and actually come up with our own MVC framework? And they realized that they could basically use React. So they could take React, and rather than rendering to a virtual HTML DOM, they could render to the tree structure that represents their current Canvas UI, which is nuts. It's amazing. This got quite a mixed reception when it came out. Everyone was very much applauding them for their technical ingenuity, but it really does feel like a crazy way to actually deliver something like this to mobile devices. So on to React Native then. So getting started with React Native, what I want to do is show you a simple demonstration of a React Native application and how you might get started with it yourself. Now, the easiest way to get started with React Native is there's a CLI that you can obtain through NPM. So you obtain this CLI. React Native applications have quite a bit of scaffolding, and also they have Xcode projects within them, which have a crazy amount of horrible scaffolding. So they've got this little CLI application that allows you to very quickly create all the scaffolding that's required. So if I'm going to reproduce that little application where you click a button and it tells you how many times you've clicked it, this is the way you get started with React Native. And this is the application. So this is exactly the same application. I'll show you it in a second, but I'll show you the code first. This is exactly the same application. And hopefully, if you're familiar with React already, this should look very familiar with you. If you're not, hopefully you can draw the parallels between the earlier slide, which showed you the click counter component. one or two differences I want to point out. First is, with React Native, it goes through a transpiler, so you can use ES6 features. So rather than using the create component function, they had a slightly ugly way of constructing components. Here we're using ES6 classes. It just improves the clarity. Also using arrow functions and so on. But other than that, it looks exactly the same. But the one big difference is here in the rendering function. And what we're doing here is, rather than returning HTML DOM, we're returning a different kind of, I hesitate to use the word DOM, but we're returning a different visual tree, basically. And I'll see if I can actually show you it up and running, if the demo works. So ignore all the junk behind. So here it is, working in exactly the same fashion, which is quite interesting. What this means is, if you're already familiar with the React concepts and the way React components work, things like state and property, how you compose components, you can take that knowledge and use it to create iOS apps. What I want to do is talk a little bit more about how this is actually working. So if you remember back to the idea of the pipeline, where you have your application state, it creates a virtual DOM, or a virtual visual tree, which is then diffed and updated. This is how it's working with React Native. The first thing is, in development, the application's being served up by a sort of development server. So it's a bit like your modern web development these days. Typically, you've got some kind of server running that's providing linting, testing, transpiling, that sort of thing. It's exactly the same with React Native. You've got a server sitting there. What it does is it serves up your React Native code together with the React Native runtime, and this is run within JavaScript Core. Now, JavaScript Core, I think, came out in iOS 6 or 7. Basically, prior to that, the only way to run JavaScript on iOS was to create a web view, and it wasn't a terribly good environment for running JavaScript for obvious reasons. It's a heavyweight way of doing that. So instead, they released JavaScript Core, which is just a JavaScript runtime. It's effectively headless. So with React Native, the code is served up from your development server, lands in JavaScript Core, and runs there in a background thread. That manages your application state, executes your application. It creates I'll call it DOM for the sake of argument. It creates the DOM, does the DOM diffing, and then what it does is it sends the updates over to the UI thread. So what happens here is you get the optimized sort of diff going from JavaScript Core to the UI thread, which constructs the real visual elements. In this case, it's UIKit, because this is iOS development. And already this is quite an interesting point, because I think every other UI framework I've used, I think, whether it's Windows Forms, WPF, or whatever else, most UI controls have a thing called thread affinity. What that means is you can only update their state from a specific thread, the UI thread. And what that means is most of your applications are written so that everything runs on the UI thread for simplicity. If you've got something computationally intensive, you have to cut that out, put it into a different thread, and then marshal back onto the UI thread to perform the updates. So it's something you consciously have to do. Here, your application's actually running in a different thread immediately. The only thing that happens on the UI thread is the real UI work. So that's an interesting technical benefit of React Native right there. So yeah, it's quite interesting. But it actually gets a bit better than that. One of the problems with iOS development, and I say iOS development, but I went back and opened up a WPF application I'd worked on years ago, and it took about a minute to compile. And I compared that to web productivity. Recently, I've been fiddling around with a build on a project that we've been working on because it took 13 seconds, which is far too long. Whereas iOS development, desktop development, most of these, you're talking 30 seconds, a minute before you get any form of feedback. Whereas within the web, we expect instant feedback. So one of the other interesting things about React Native is it actually improves the developer experience. So I want to quickly show you some of these things. So here we have the application running, and if I can quickly locate it in the background, hopefully, yeah, I'll zoom a little bit. Hopefully that will be readable. So here we have our application, and what I'm going to do is just make a trivial change, save that file, go back, click refresh, and it happens almost instantaneously. You can't get a developer experience anywhere like that with iOS development. What you can also do is enable live reload, which again is very classic sort of web development. So I don't even have to refresh. As soon as I save my changes, the watcher pushes the updates to your simulator, and off it goes, which is really cool. Also, as you'd expect, you can debug in Chrome. Oh, blimey, where's this going to appear? Okay. So here we can actually see hopefully it's down here somewhere. You can actually see the source code for the application. You can set breakpoints, for example. So I'll set a breakpoint there. I'll press that, and I've hit my breakpoint. And you can obviously do things like, I don't know, let's quickly do a... Can't type with people looking at me. So what I've done is I've updated the state, so the background color is yellow. And there, you can make live changes to your code, which is pretty cool. And again, in terms of development tooling, the web has got some of the best development tooling at the moment. It's certainly far better than the built-in iOS debugger, and the same is true for a lot of the development I used to do with things like WPF and Windows Forms. Because there's so many people working on the web, the tooling is improving at a considerable rate. So it's really great to be able to use that. Let's find my screen. There we are. OK. One thing that's a bit of a shame is if you've got the React development tools installed, when you debug a React application, you can actually navigate the React component tree. That worked for React Native until about 2 weeks ago, and then it broke. And the issue has got some rather disappointing, "It's broken, don't know how to fix it" comments on it. They did some significant changes to the way it works, and then suddenly realized they couldn't make it work anymore, which is a bit of a shame. Also, in terms of development experience, this is a web application now, so you've got all of NPM, all those packages at your disposal. Basically, any package that doesn't touch the DOM is good to go. So say, for example, you want a markdown parser or something like that. You'll find one of those on NPM. Also, you've got Babel, for example. So rather than writing old JavaScript, you can write ES6. So you've got classes, arrow functions, destructuring, templated strings. And most importantly, you've got web productivity, which is really cool. Another big thing that React Native brings is layout. And when I first started iOS development a few years ago, I really thought this was great because there are only, well, I'll tell you what this slide means first, actually. So this was from a blog post from Android Authority, and what they did was OpenSignal have an Android app and an iOS app, and what they've done is they've instrumented it to find out the distribution of screen sizes. On the left is Android, on the right is iOS, and this is probably quite familiar to you. Android has a wide range of screen sizes, which means from a development perspective, you've got to design UIs that work in so many different configurations. On the right is iOS, so you've got iPhone, I don't know, can't remember when this was. It's probably iPhone 4 and iPhone 5. I think that's when they made them a little bit bigger. And then you've got iPad mini and iPad, which from a developer perspective are exactly the same screen resolution. So when I started doing iOS development, it was great. You used Interface Builder, you dragged stuff onto the phone, and that's exactly where it appeared. Unfortunately, it's not like that anymore. They've released quite a few different screen sizes. iOS 9 means you've got split screen in iPad. So basically, iOS developers can no longer poke fun at Android guys. They're in effectively the same boat. But unfortunately, they're in the same boat, but it's a bit worse. The way that it works with iOS is they've got this thing called auto layout. And the way that works is you construct your UI by positioning elements and adding constraints. So this is an example from their documentation. What this means is I've got these two elements, and I've added these constraints that say it must be 20 pixels from the top or 20 from the right. And I think with this layout, you can probably see that it flexes the A's as a result. It's really, really horrible to use. It's okay in trivial cases, but as soon as you start building application user interfaces with auto layout, you continually get shouted at by Xcode for having conflicting constraints or not having enough constraints. And basically, from my perspective, it gets to the point where you just can't understand your layout anymore. In the world of JavaScript, layout from an application perspective hasn't been great for a while until recently. Things like Flexbox specifically target some of the weaknesses that CSS Layout has. And what the ReactNative team wanted to do was they wanted to bring another familiar web technology. They wanted to bring Flexbox to iOS. And they went about this in quite an interesting way. What they've done is there's an open source project called CSS Layout, which is a JavaScript re-implementation of Flexbox. So what you can do with CSS Layout is you can give it a node tree. Now, this is pretty trivial. I think align self is the only actual Flexbox attribute in there. You give it a node tree. You tell it to compute the layout. I know it goes off the bottom of the slide, but basically it computes the Flexbox layout and tells you the boundaries of each of the components, which is really cool. And it was very interesting the way that this was developed. They did it through a sort of extreme TDD approach, where the guy developing it was implementing it and testing it against Chrome's real Flexbox implementation. So adding a Flexbox attribute, writing the code, testing it against the real implementation until after a couple of weeks of iterations, he'd completed the whole thing. It's then been transpiled to Java, C, and C#, and it's a really interesting project. And it's one I've been getting involved in a little bit, helping them with the build and test, because it's quite a challenge doing the build and test across all these languages. Interestingly, you might expect that React Native would run the JavaScript implementation within JavaScript core. It doesn't actually do that. And the reason is the layout algorithm actually requires quite a lot of conversation with the real UI for things like text measurement. And there's an inherent overhead of crossing the boundary between JavaScript core and the main thread. And it's also asynchronous as well, which is an issue. So what they use is the C version from the transpiled JavaScript version. So again, from a technology perspective, it's pretty crazy, re-implementing Flexbox by TDD development against Chrome, transpiling it to C, and then running it over there somewhere. Again, it's cool. It's very cool. One thing that's also a bit cool is, I don't know if some of you saw the talk that my friend Chris gave, but we've been messing around with D3 quite a bit. This is a bit of a tangent. And one of the things that we've found quite frustrating about creating SVG graphics is SVG doesn't really have layout at all. All you do is you position things using absolute coordinates, which, if you're wanting to create a chart, I'm sorry this has gone off the bottom of the screen. I've boosted the font size for everything quite recently. But if you want to construct something like a chart where you've got axes and legends and so on, you really want some kind of layout algorithm so you can express it in understandable terms rather than pixel coordinates and doing all the little maths and having to add bits and subtract bits. What we were able to do is take the Facebook CSS layout engine and apply it to SVG. So you can see the layout CSS attributes gives the Flexbox style. We do a selection, call layout, and it positions everything as a result. So that's a bit of an aside, but what I quite like about this is it demonstrates the fact that because they decided to pluck that little bit of functionality and put it into a separate open source project, we were able to use it for something completely different to what they originally conceived the project for. And there are other people using this for all kinds of crazy things. So I've shown you a very, very trivial application. What I want to do is hopefully show you a slightly more involved application. If you just bear with me. What I thought would be nice would be if the conference had its own application, because, you know, every conference needs an application. You can't check the website. That wouldn't work. So what I did was I created a Bristech conference website. Fingers crossed, hopefully this will work. So what you can see on the left-hand side is you can see the development server starting up, the packager, loading a load of stuff, and here we have the conference application. So you can scroll through the list, you can click on people and read a little bit about them, images, that sort of thing. what I want to do is quickly show you a few of the more complicated bits behind that. I was going to show you them in Xcode, but I can't remember how to zoom it, so I'll show you in this instead. So let's start at the beginning. So let's have a look at the application. So one of the things that you'll probably learn through a quick tour of this is initially this looks quite similar to web development. With the click counter application, it had a lot of familiar concepts. You have views, which are a bit like divs. You have text, which is I don't know, a bit like p elements or something like that. To construct something like this, you're going to depart a little bit from some of the things that are familiar to you. So the actual conference application, the starting point is this component called Navigator iOS. Navigator iOS is mapped to, I can't remember, mine's gone blank. It's UI something or other view controller. Any iOS developers here? There's a particular view controller that manages a stack of views and gives you this kind of forwards and backwards functionality. So you can see that the application's using things that are quite tightly coupled to iOS. If we then move to the list, for example, the list is using, the scrolling list here is using quite a specialized component. Here we're using the list view. Again, we're starting to introduce components that have quite a close correspondence to native iOS components. This one's very like the UI table view. To get good scrolling on iOS, what they do is they recycle the rows. There's quite an overhead to constructing new view elements. So what they do is they maintain a pool and recycle. So one thing I want to point out here is that if you're doing React Native development, it doesn't entirely decouple you from the way that iOS renders views. You have to start to understand how iOS applications are composed. 5 minutes left, so I'm not going to show you all of that. Oh, one other one. Yeah, talk details. This is quite fun. This is something completely different. One of the things I pointed out was when talking about knockout is they generally have a kind of mini language for iterating over arrays and templating. With React Native, well, with React, what you can do is just use familiar JavaScript concepts. If you've got an array of items that you want to render, rather than having to have a kind of for each syntax within your HTML, you just use a map. And here I'm just transforming my description array, so multiple paragraphs, into a number of text UI elements. Again, that's really quite nice. There wasn't time for, and I'm going to say there wasn't time for things like animations because I haven't learned properly how to do animations in React Native. They've got their own kind of declarative form of animations with tweening and so on. To be honest, I haven't had a go with that yet. Native component interface. If you want to use a component that isn't already present, they have their own relatively easy to use interface for taking an Objective-C class and exposing it to your React Native code. Also Android. This only came out a couple of weeks ago. It's exactly the same concepts. You're just creating Android UIs. And interestingly, Facebook have reported that they've managed to share 85% of their code between iOS and Android apps. A quick look at the good and the bad of React Native. I think the best thing is their overall goal here. Rather than focusing on trying to share as much as possible from a single code base, what they're going after is learn once, use everywhere. What they want to do is make it a familiar environment rather than having a single code base that runs on web, mobile, everything else. They just want to bring the same tooling so that developers can move from one platform to another. The bad, there is always a bad, and I really love this quote from Joel Spolsky. All non-trivial abstractions to some degree are leaky, and the same is true for everything that is an abstraction layer. And if we look at the potential leaks with React Native, the first is obviously bugs in the abstraction layer. If there are bugs in the way that this thing works, then unless you want to dig into their code and fix it, which could be fun if you've got the time, if you want to ship something, that's not so much fun. That's a leak. You've got a great big third-party dependency there as well. Apple has a habit of making pretty bad breaking changes from one iOS version to another. And you've got quite a dependency now on someone else to fix that. Also, abstraction layers hide features. This is typical. If you're abstracting something, typically you don't expose everything. So there are certain things that are going to be hidden as a result. Also, the big one is, will Facebook still be using this in 2 years' time? If not, it's up to you to maintain it. I know that all sounds negative, but you really have to bear these things in mind. I'm actually going to skip through those because we're running out of time. One thing I do want to point out is if you do want to give React Native a go and you don't have Xcode and a Mac, you can actually do it on the web, which is quite interesting. Now, I'm going to show you this, but it's almost certainly not going to work because it's been working every time I've used it. This is called the ReactNative Playground. It's web-based. You can write React Native applications in a web editor. It's a bit like JS Bin, CodePen. And it's got a simulator here, which this wasn't working half an hour ago, so it's, wow, it's working, blimey. So here you can see exactly the same application working on the web. And this simulator here is actually a Mac running as a virtual machine. So basically, this is a real simulator running somewhere else as a virtual machine. I have a feeling that this will be around for a while, but unless they find a business model and way of funding it, this is going to be killing them. It's going to be expensive. So yeah, if you want to have a go with it, by all means, have a go with React Native Playgrounds. I've got a few other applications there. For example, this is a property finder application which I wrote, which is a little bit more complicated. And yeah, this is my parting thought. To my mind, React Native, more than anything else, is an exciting mix of technologies and techniques. And through looking at React Native, personally, I've learned a whole load of new things. I hadn't even done React before I did React Native. And if there's anything you can take home from this talk, hopefully it's just that. Thank you.